All right. Log in here. I don't remember which account it was, but let's just go with that. Okay, good. Make this text a little bigger. Let's go down here. Okay. Oh, hold on. I'm going to stop sharing for a second because I need to plug my share into the fire screen. Both of these. We'll share the screen. Make sure we're still recording. We are. So you get to knock me for not prepared for class. So let's go with that. Maybe I won't give you a crazy homework assignment for Thursday, mostly because I need to finish setting this thing up. Okay. So for we did have homework for today, right? So inside of player, okay. We were supposed to do some randomly setting some stats and then a display method, that kind of stuff. Okay. So let's go ahead and work on that and then maybe get a couple of um, players trying to kill each other, that kind of stuff. Yeah. More sooner we can get to violence, the better. It seems like that's all right. Um, and this font big enough for everybody? All right. All right. So we are going to set hit points to be a value between 15 and 30. All right. So remember, we have this dice class here where we build a dice using a number of sides. And if you remember from last time, we talked about the random number generator and we talked about seed values a little bit. Those are things I'm not going to like test you on in here, but just something you should throw into the back of your mind in case in the future you're ever working with a programming language, usually older languages. We did we do random numbers in C++? Okay. Well, if you were to do random numbers in C++, we use a library called rand, and then but we have to use it along with another library called srand, or another function called srand, which seeds the random number generator. And we usually seed it with another function called time. We pass it null. That'll give us the milliseconds off the current clock. And we just use that as the random seed since, if we run the program multiple times in a row, as long as we're at least 1 millisecond in the future, we'll get a different collection of random numbers. I presume that's what Java's doing behind the hood, under the hood here. I think I mentioned this exact same random class years and years and years ago would have produced the same random number string every single time, but now it doesn't um, because it's preceding itself. Which can sometimes be a little frustrating. I probably mentioned last time that there are aspects when having random predictable numbers are good for testing. when you're looking for bugs and stuff like that. Ultimately, once it's prime time and you want to release it, you want it to actually be random, but such is life. All right. So last time what we had done is when we construct a dice, we take in a number of sides, we set the sides field for this guy that we have made private. So we've been working with public, private, protected, not protected yet since we haven't gotten into inheritance yet, but private means you are only allowed to access directly this field from within the class called dice. And that's actually an important caveat that I don't remember if I pointed out when we were working with fractions. Um, listen to the sentence I say. Sides can be accessed anywhere inside of the class called dice. Notice I didn't say this particular dice. If you were, and you maybe ran into this when you were working with your add function for fractions, where we took in a second fraction as a parameter, and we were able to access that second fraction's numerator and denominator directly. We could say f dot numerator, f dot denominator, even though we were in a different fractions version of add. But because we were still inside the fraction class, we legally could access those private members of another fraction. Okay, it's nuanced, but it's an important caveat. So when we say something is private, it is accessible anywhere inside of the class called dice, regardless of which instance of dice we're currently sitting inside of. So if I am sitting inside of this dice and I'm working with an instance of another dice, let me just kind of give you that to you as a example. Let's say public void do something, and we'll say this guy takes in a dice D as a parameter. Even though D is a different instance of dice than this, I am allowed to say D dot sides. I can access the private sides field of D, even though I'm currently not inside of the instance of the dice class that had its do something called. All right, so this is legal, even though it is a different dice than we're currently sitting in, because we are inside the dice class. All right, there was a question over here.
Yes, if you share somebody or like a file, and does the public mean that they have access to editing and like the private means that they don't, or is that just like specifically for the code? Like it doesn't have to do with, your
Okay, so the question was, if you shared your code with somebody and you have it private, does that mean it's available for editing?
public, if it's public, anybody can access.
If it's public, anybody can access it, and maybe access is not the best way. Anybody can change it at will. So really, this comes down to a read only versus write only versus nothing. When you have it private, it is not directly accessible anywhere outside this file, regardless of who has it. Okay, but that's kind of the point I'm making here. Let me just push it a little bit farther with another example. So what did I call this guy? I called this guy do something. So I'll go ahead and we're going to say woot dot do something, and I'll pass it D20 in my stupid little example function I just made. So woot is my instance of dice that is calling do something. So if I follow that in here and I go into dice, inside of do something here, this is woot. This keyword refers to this particular instance of dice. And the guy who called his do something function was named Woot out here. Woot called his do something. All right. So inside of this particular call to do something, when I say the word this, so like this dot sides is equal to 4 or something like that, just hard coded. Okay. I'm allowed to do that because this is Woot's version of do something, and sides is private. But I can also say d dot sides is equal to -2 if I wanted to, even though I am not sitting inside of the instance. In this case, d is d20. All right. Because inside of dice, do something took in a parameter, some instance of the dice class. So I'm calling it D inside of here. But when I passed it in, the guy I passed in there was D20. Okay, so inside of the code here, when I say D, is D20 in this example. What I'm saying is just because I made this guy private, you might think that I am not allowed to access a private field of a different instance of dice inside of another instance of dice. That is not true. If I am in the file, if I'm in the class called dice, regardless of who owns that private variable sides, I can access any instance of dice's sides variable directly as long as I'm in this file. All right. This may not come up very often for you, but it is a thing. Every now and then you might say, well, I need to access this other guy's version of sides. Well, do I need to call d dot like get sides? Do I need to write a getter for it in order to get it, or d dot set sides to -2? Ay, ay, ay. Something like that. We haven't written getters or setters yet, but last class we were talking about getters and setters, the idea of how do we give some level of access to private members of a class from outside the class. We do that through getters and setters. We typically will make all of our fields private. And then if we need to loosen the reins, we will, but almost always you'll leave your fields private. I would say good programming practice is fields should always be private. I can't think of a good example other than I probably use the example of once you get good enough at programming where it's quicker for you to just write some code real quick to solve some stupid problem that you're then going to delete 5 minutes later. Maybe you don't want to waste a whole lot of time writing getters and setters for something that you're just going to use real quick. But outside of that, good programming practice would be always have your fields be private and then give the type of access you need. So most of the time you might say, well, I want maybe external entities to be able to get at this value directly. Therefore, you'd give it a getter. You might, so that's read-only access. If you want them to be able to change the value, you would make a setter, which allows them an external entity, something outside of this class, to make changes to that variable. You might also decide not to have any getters or setters. In fact, that's probably the most common way of dealing with it, is that, hey, these are fields, they belong to the dice class. But if you ask yourself, if I have a dice right here, an instance of our dice class, do I actually need to directly access the variable called sides? Or really, do I just need to be able to roll this guy and internally it will have access to sides, whatever, to do its thing? I have an instance of dice with the purpose of rolling it and getting a number out of it, right? I don't actually need the dice to be able to give me the number of sides it has. You could, but that's not a requisite for being able to use a dice. A human being can look at it and say this is how many sides, but as soon as they start getting enough sides on it, it becomes confusing. So then you stop counting. But I would say typical programming practice would be fields are always private, and you actually will not necessarily commonly have getters or setters for these guys. For probably a majority of your objects. It's not that those are rare. Getters and setters are not rare. It's probably just not necessarily the common case. It's how we poke holes into a object to give ourselves access to things that we want to control access. We don't want them to be able to change the value of sides. So even if we did want somebody outside of the dice class to be able to have access to that variable called sides, we might only want them to be able to read it, see what the value is, not modify the value. Therefore, we would make it private, and then we create a getter to expose that value in a non-changeable way, if that was important to us. Okay. So a little bit down the rabbit hole, but this is an important thing to understand because at some point you're going to run into this and it's not going to be an error. And you might wonder why it isn't an error. Because it is private, yet we're talking about a different instance of Dice's fields. As long as we're in the class, you're allowed to access them. All right, let me dump this guy. Dump this guy. All right. So inside of player, we want to go ahead and when we create our player, we want to create a player with just his name. And then we're going to randomly generate the stats inside here. All right, so we decided hit points is going to be a value between 15 and 30. Now we could hard code these things right here if we want. So for instance, to create a value between 15 and 30, we can create one of our dice, right? Okay, so how many sides? If we create a 15-sided die, it's going to give us a number between 1 and 15. And then we add 15 to that. That'll give us 15 to 30.
You only give 16. You only have a one.
Oh. So if we'd have to take it, subtract 1, then add 14. Add 14 to it. We'll get it done. So let's create a dice. HP dice is equal to a new dice, and we're gonna make this a 14-sided dice, 1 to 14. Is that right? No, we're gonna make it a 15-sided dice, and then we'll add. Let's 16, 1 to 16 and add 14. Thank you. All right, so then we can say this dot HP is equal to HP dice dot roll plus 14. Okay, so that'll get us our hit points. Dice. Now we could redefine our dice if we wanted to here, but we'll just keep going down the path. So we'll call this guy strength dice is equal to a new dice. And we decided strength would be a value between 8 and 12. So we'll have this be a 9-sided dice, a 9-sided die. This dot strength is equal to strength dice dot roll plus 4, 3. 3. No. 9, 10, 11, 12. Yeah, 3. All right, so that'll give us some value between 8 and 12. And then dice.
Add dice, you get.
That'll give us oh. Hold on, let me think about this. So we want to get a minimum value of 8. So minimum value of 8 is going to require a 8-sided die plus 8. But we want to be able to get up to 12. So using our dice for this becomes more confusing if we just, it would have been easier just to generate a random number, but we really want to force the use of dice. Go ahead. You want to do 5? We can mod it.
Get a max minus min, divide by min or something.
Yeah. I guess we could do that. We can just roll a dice, a 100-sided die, and then mod it from there to give us the right range. So I suppose we could do that. We can say dice D100 is equal to a new dice with 100 sides. And then for our hit points, We'll say D100.roll. So that's going to give us a number between 1 and 100. And then we want to mod that by, we want our low value to be 15. So we mod it by 16. That'll give us a number between 0 and, well, actually, the lowest number would be 0. 0 to 15. And then we can add 15 to that, which would give us a value between 15 and 30. I really just want to use an instance of the random class to do this, but I want to force our dice.
The 5-sided +7 makes 8 to 12.
Yeah.
All right, let's just go down. Let's just keep doing what we were doing. All right, so 5-sided +7. Right, and then dice AC dice is equal to a new dice, and this guy should be what, 3?
Yeah, 13 + 4.
Oh, 13 plus 4. This dot AC is equal to AC dice dot roll +4. Okay, so we create 3 different dice. We use it to roll these things up, sort of, I don't know, junkily, let's say. Well, it's not that natural, but we did it anyways. All right, so we will, those will have our values. Then we want to go ahead and create a display function. Public void display. And we don't actually need this to be public, but it's common to do that. Make it public if you want anybody outside of this to access it. Make it private if you want it to be only accessible inside this, that kind of thing. And then we'll probably just kind of give our stats. So we'll do something like system.out.println. Maybe we say something like name concatenated with this dot name. And then we'll have HP, strength, and AC. So we'll say HP. I'm going to steal this line. This will be strength. .str. And then this guy will be AC. .ac. All right. If you want it to look a little pretty. Like that. All right. So now we taught our players how to display themselves. So we'll go ahead and save this. We will go out to driver. We're going to get rid of these dice here. We'll go ahead and create a couple of instances of players, and player P1 is equal to a new player, and we'll call this guy Mike. Player P2 is equal to new player Dave. I need to make sure I give the player P1 some extra bonus rolls. Dave's my brother, and I can't lose these fights. I was the big brother. Okay, so then we'll go ahead and say P1.display, P2.display, and we should see our random values pop up here. So Mike, 19 hit points, 10 strength, 8 armor class. Sounds about right. I'm more robust than him, probably stronger than him, but maybe I'm a little bit soft. Couldn't take a punch very well. All right, but we see we got a couple of random generated people. All right, so does that do everything for the homework? All right, go ahead.
So when you have different classes and stuff, is that just like the same as, if you're, a warrior or a mage, you could like have different like, sets of.
We're going to be going down that line when we talk about inheritance. So for the online folks, what he was asking about, you know, I think I mentioned last time, how many of you have heard of Dungeons and Dragons? I should put up a video. There was a video game from years ago called Summoner. Older than most of you, I think, are, but they had a promo for Summoner called what was it? Well, in any case, it was kind of a cartoon promo for it where all like the monsters and stuff from Summoner were sitting around a table playing tabletop Dungeons and Dragons. I think it was called Summoner Geeks was the name of the video. I'm sure it's on YouTube or whatever. But it shows them all sitting around a table, rolling dice to attack. You're in a dark, there's orcs. Somebody casts this light, so like I'm gonna attack them, blah, blah, blah. Another person said I cast spell XYZ. Says, no, you bought the components for it, but you didn't actually cast it. Now there's orcs. Okay. The end boss in this game was like a monster who was, I guess, hanging out at the tavern outside of this dungeon they're in. But it gives you a feel for how geeky old school geeks were when we didn't have the computer games that we have today to do stuff. But the question that was asked was in those kind of games, we have these different classes, like there's warriors and mages and rangers and all sorts of different things. And each one of these might have some special, a warrior probably has more hit points and strength and armor class than a mage might have. They're weaker physically or whatever. Well, we're going to accomplish that when we start talking about inheritance, where we start off with a generic player. And then we might say, well, eventually we're never going to have generic players in our game. We're going to make it so that we cannot create instances of players. So we're kind of faking it right now. The way we do that, we'll talk about this, is by making player an abstract class where it isn't designed to create instances of it, but we're not there yet. So the idea is we never create a player. Instead, we create warriors or mages or rangers. And those guys would be players, but a little bit more, or some deviation from them, as that's where we're going with this. Okay, so now we want to go ahead and start getting these guys to fight each other, right? So we've given them some stats. So we kind of have to follow the rules. If you really want to mimic something with real life, there's an open source gaming system called D20 Gaming System where you can go and look that up to make your game compatible with D20. But we're just going to kind of fake it here because we're not going to go full bore on this whole thing. But if you want to take it to the, keep going with it, feel free. All right. So what we want to do is we want to kind of create a battle type situation. So we're going to create another object. And when we start thinking about the objects that we have here, maybe we call it the arena, right? Arenas are where two players come together to try to beat each other up. All right. You can call it whatever you want, but we're going to go ahead and name it arena. So I'm going to create a new file. We're going to say arena.java. And this is going to be public class arena. All right. Now, our idea here is that in our arena, two players will fight against each other. That's what we imagine, thinking like a boxing ring or something like that. So we'll have to throw two players into the arena, and then somebody rings the bell and they go at it. All right. So when we think about the fields for an arena, we at the very least need to know about the two players that are going to be fighting each other. So we're going to make them private initially. We'll say player, call this guy player one. Let's just call it P1. Good enough. Private player P2. Then we have our constructor. Remember, constructors have the same name as the class. This guy will take in a player P1 and a player P2. We'll set this dot P1 equal to P1. This dot P2 is equal to P2. All right. And here, we can just prove these guys are working by saying this dot P1 dot display. This dot P2 dot display. So notice how we can link these things together. It's P1 calling his display method. Well, I want to call it off of the P1 that is owned by this instance. So I'll say this instance is field P1, call your display method. This instance is field P2, call your display method. So on and so forth. All right. How do you know that that's a field and not a method or a constructor? Fields are the easiest to identify, right? Look for parentheses, don't see them, must be a field, assuming it's accurate code. All right. This guy is a method. We know it's a method because it has the parentheses. So it's either a method or a constructor. We don't see the new keyword anywhere around. So probably not a constructor. And it doesn't match the name of any of the classes that we've written. So constructors have to match the name of a class. This guy's a method. All right, so we'll leave arena at that for right now. So we'll go back out here to driver. So now we're going to start bringing into light this idea of when I said that all programs begin and end with main. Main is going to, as you get bigger and bigger and bigger into your projects, main is actually not going to get very big. Main is kind of your quarterback, and he's going to be calling other things. So in this case, I'll go ahead and I'm going to create I have my couple of players. I'm going to create my arena. Call that guy the ring is equal to a new arena, and I'll pass it P1 and P2. So bring a player into existence, bring another player into existence, bring an arena into existence, and build it with my two players. Why do I do that? Because my arena expects me to pass it two players to build one. What's it going to do with those two players? It's going to set its internal private fields to those two players. And then for right now, it's just going to display them, showing that we got the information in there. We'll probably take those couple lines out here pretty soon. Because realistically, what would probably happen is when we tell them to fight, it'll probably show the condition of the combatants initially. And then we'll go back and forth until somebody dies, maybe each time show the current condition, getting hit, that kind of stuff. All right, so let's go out here. We'll run this. So there's our arena constructor saying, here's your couple players. Oh my gosh, look at Dave's hit points on this one. Oh, and look at my armor class. I don't win that fight. The dice rolls will forever not be in my favor. My brother's this little scrawny kid. No, this is when you run. As you might imagine, I have incredibly mediocre foot speed. Unless I get going downhill, then I only have to worry about stopping. All right, so now we have this built into our arena. So we know our arena is getting these variables. So let's go into arena and we'll go ahead and take out those print statements there. All right, so once we have the arena and we load our couple of players into it, think about the beginning of a boxing match, right? Maybe not like the Tyson one, a real boxing match. How many of you watched for 4 hours until the fight finally came on? Were you able to actually stream it or did it lock on you? Oh,
Netflix was just spinning.
yeah, that happened to me. Netflix was spinning on my TV, but I was able to watch it on the iPad on Netflix. For some reason, they must use a different feed for streaming to their mobile apps. But money grab. Who wouldn't do that? Just get buddy with Mike Tyson, have a fight. You just got to take one punch.
With the Paul,
Hmm.
that's what the Paul brothers do.
Oh yeah. Hey, good business model. All right, so we're going to go ahead. We'll create a function. It's not going to return anything. This is going to be the function where we tell the arena to start fight, I guess. Let's call it start fight. Probably don't need any parameters to start the fight. So if I'm the arena and I call my start fight, the idea is that my combatants on the inside, they start fighting, right? And typically, these types of games are turn-based games. So we have to decide who gets to go first. And they take a swing and so on and so forth. It goes back and forth until somebody keels over. Something like that. All right, so we need to decide how we're going to actually take a swing. What are the rules of our game? All right, so with players, we have hit points, which is our kind of life force. So that's the thing that'll go down as they get struck. We have their strength. This is probably how hard they hit. And then we have their armor class, which is based on how good their defense is. All right. So typically in a fight inside of our arena, I'm going to go ahead and give ourselves a private dice D20. Inside the constructor, we'll go ahead and say this .d20 is equal to a new dice with 20 sides. We just have that guy ready to go. All right. So now we need to decide who goes first. I guess for right now, we'll just assume player one goes first for no other reason than just to kind of get to the fighting here reasonably quickly. All right, so we're gonna say player current attacker is equal to this .p1. Player current defender is equal to this .p2. So we'll just generically label who's the attacker and who's the defender. So the attacker attempts to attack the defender. How do we attempt to attack the defender? So we'll say attacker attempts to attack the defender. So we might say attack roll is equal to this d20 roll. So we'll tell our 20-sided die to roll itself, get some number between 1 and 20. That's stored inside of attack roll. Now, we might say, well, when we try to attack, the attack is successful if it's at least as big as their armor class. You could also say greater than their armor class. It's kind of up to you. It's the difference between a greater than or a greater than an equal to. So if attack roll is greater than or equal to current defender dot, we want this guy's armor class. So now this is where the private stuff starts coming in. So we really want current defender's armor class. The problem is when I go and look at player, we see armor class is private. Private means it's only accessible inside of a class called player. Right now, I am inside the class called arena. So I do not have access to current defender's armor class directly. So I need to go ahead and give myself a getter since I do need to get that value. I don't need to change that value, but I need to be able to retrieve their armor class. And it's a private variable. Now, why wouldn't we just make armor class public? Why wouldn't we just fix this by going ahead and coming in here and say, okay, well, we need the armor class, so we'll just make it public. Why is that a bad solution? Go ahead. Yeah. So now, yes, you made it public. So now this line of code no longer would break because now you can access that outside of the class, but now you have full access to it where you can change it and that kind of stuff. Is that the end of the world in this little stupid game? Maybe not. We're the one coding the entire thing. We can just say, okay, well, I just won't change it. But good programming practice would be set the stuff up to be secure and then only provide access as you need. So we would leave this as private. And then what we would do is we would give ourselves a getter. I'm going to go ahead and minimize these things just so it's a little bit easier to see. Little drop down thing here. We can go in and change the code if we want, but this makes it a little bit. Apple keeps calling me. I wonder if it's related to this thing. All right. So we're going to go ahead and we're going to say public, and we are writing a getter for our armor class. So that means it needs to return an integer. We'll call it get AC. Remember that a getter doesn't have to be called get something. That just tends to be naming convention. A getter is a normal method like any other method. It just happens to return the value of a private member by design. And we will return this .ac from that guy. All right, so that's all the getter does. This guy is public, so this guy can be called from outside of this class. AC is private, which cannot be accessed directly outside this class, but right now get AC is inside of the player class. So he does have access to AC. So he can return that value if he wants. That's the concept of a getter. So now out here in the arena, we could say get AC. So if the attack roll we just rolled, which is a roll of the D20, is at least as big as the defender's armor class. We have hit the defender. And what we're going to do is we'll go ahead and write an else to this. That way we can get a little color commentary out there, kind of like you swing and miss, something like that. So if I'm in this else, we missed. So you could do something like system.out.println. You swing and miss. And actually, what we might do is we might want to get the name of the person. All right, so we might want to say Mike swings and misses or Dave swings and misses, which means that we need the name of our players. Go back into player. Name is also private. So if I want to give access to the name, we would need to give ourselves a getter for that as well. Public name is a string. We're in Java, so that's a capital S. Get name, return this dot name. So there's our getter for the name. So here we might say current attacker dot get name. Swings and misses. Now we could put some other logic in here. Sometimes you have in real Dungeons and Dragons, let's say when you roll your D20 and you roll a 1, an epic miss or whatever, critical miss. So you might end up like stabbing yourself in the foot or something, doing some damage to yourself. We could always um, ask that. So we could always throw some more logic in here and say if attack roll is equal to 1, a critical miss, then we might say current attacker dot get name stumbles and stabs themselves in the foot. And right now we'll just give commentary, but we could actually make them hurt themselves if we want. Obviously, you can see we can keep going down this path and saying all sorts of if statements. Remember, all hard programs are made up of a bunch of easy parts. If statements, variables, loops, things like that. So here we could just keep asking questions. If you had a bad attack roll, we can say you fell over and stabbed yourself in the foot. Maybe you take 1d4 worth of damage or something like that. You can go wild with it if you want. But we'll just for right now, we'll just do it all with verbiage. So we'll say we missed if we missed, but if we critically miss, we'll just kind of mention we stumbled or something like that. And if we wanted to, we could do something like critical miss. Maybe put a couple of asterisks before and after that to kind of have it stand out. All right, so something like that. All right, so that's what happens if we miss, but if we hit, that means we hit the defender. So now we need to go ahead and roll damage, how much damage we're going to do. All right, so in regular Dungeons and Dragons, you have all sorts of modifiers and stuff like that. Like if your strength is above a certain thing, you get +2 to your damage rolls or whatever. We're going to keep it simple. Damage is always 1d4 for right now. You can do whatever you want with it. We're just keeping it simple for our examples so we don't get too crazy with it. So inside of start fight, let's go ahead and give ourselves a dice. Call this D4 is equal to a new dice with 4 sides. And we'll just decide that this is our damage dice. Okay. Now we could make the argument that we give ourselves our set of dice up top in the arena, but we'll just go ahead and give ourselves our D4 down here. We'll move it if we need to. So we've hit the defender. So we'll say damage is equal to D4.roll. So now our variable damage holds some amount of damage between 1 and 4. And we want our player 2, our defender, to take that damage. All right. Now, when we say take damage, what does that mean? It means that their hit points should go down. So we need to modify their hit points. Well, so we're really saying current defender dot HP is equal to current defender dot HP minus damage. That's the logic we want to set. But we have all sorts of issues with that right now because HP is a private variable. So go back into player. Here's our hit points. We could always make that guy public if we wanted to, since we might want to also be able to get the hit points. But perhaps we want to control how hit points is reduced. So we'll just do a setter for this. So we'll say public void set HP. Actually, what we're going to do, we're not going to call it set. We're not going to make a setter for it. We're just going to have a public void take damage. So all players now know how to take damage. They take an amount of damage in as a parameter. and they set their hit points equal to however much damage they were supposed to take. All right. So back here in arena, after we have our damage, we're going to say current defender, take damage. The amount of damage they're going to take is the roll of our D4. All right. And then we will assess the situation. So our defender just got hit. Now, is the fight over? How do we ask, is the fight over? Okay, so if they're dead, right? If they're although we'll be less fight if they're unconscious. Except if they roll a 20, then we might allow them to decapitate the so you have fun with it if you want, but what's this? Yeah, but if I rolled a natural 20 for my attack roll, we can put all sorts of like scalars on that. Just multiply it by 100. Have them scream, there can be only one. All right. So we'll have them take damage. Now we might want to be able to, if we kind of, we're trying to think about this in an object-oriented way. So a good way to start thinking about it is pretend like we're in this play, or you're standing ringside and you're the ref and you're assessing what's going on. Okay, so this guy took a swing at this guy. He hits. Okay, how hard did he hit? They figured that out. Now he took damage. Now you're going to say, okay, buddy, are you okay? Okay, you're going to ask the defender if he's alive. All right. So we want to have players being able to report whether or not they're dead or not. Okay. So we'll go ahead and say public Boolean, call it is dead. Now, a player, remember, this is inside the player class. So if I'm a player and somebody asks me if I'm dead, I'm going to internally check my hit points. And if they are 0 or less, I'm going to return true. I'm dead. If they are still greater than 0, then I'm still kicking. I'll return false. I'm not dead. So I can return, we want it to return true if our hit points are 0 or less. This dot HP less than or equal to 0. That's what it means for us to be dead or unconscious. All right. So now, after the defender has taken some damage, we know under this circumstance, he may have just died. So now we need to ask the question, if current defender dot is dead, which will be a Boolean, right? So if that's true, if he is dead, then the other guy won, right? And we're done fighting. All right, so the attacker then won. Now what we can do is we can have a player announce that they were the winner, or we can internally announce, or inside of arena, we can have a talk about the player. Remember, the name is private. We don't have we do. We already gave ourselves a get name for our other printouts. So if we died, we're going to go ahead and say system.out.println. The winner is the person who just attacked, right? So current attacker dot get name has won the fight. Now see how I'm dealing with these guys generically? I originally set my current attacker to P1 and my current defender to P2. So I can reference them as attacker and defender. Now, after we finished one round where presumably whoever got hit is still alive, Now I just have them switch roles. The attacker becomes the defender becomes the attacker. All right. So if he's dead, we'll announce that he's dead, and we want the fight to be over. So how do we stop the fight? Make it return. Now this guy is void, but we can still use return to make this function immediately end. So we'll go ahead and say just return, which basically means stop fighting. All right. Now, if he's not dead, now he's not dead under two different circumstances, right? Either he got hit and he still has enough he still has greater than 0 hit points, or the attacker missed. So if we get to this line after the else, if we are still alive here, that means one way or another, the player, the defender is still alive. He's still alive either because he took a hit and didn't die, causing the function to immediately end, or they missed him. So any way you cut it, if we get down to this line of code right here, we need to both our combatants are still alive, and we need to have them switch roles. So the next time through, which we haven't written our loop yet, but the next time through, the attacker and the defender have switched places. All right. So we'll go ahead and say player temp. We're just going to say switch roles. Player temp is equal to current attacker. Current attacker is equal to current defender. Current defender is equal to temp. So we needed an extra little variable there to do the switcheroo. Otherwise, we would have overwritten either the defender or the attacker. So we preserve the attacker here. Then we overwrote the attacker with the defender. Then we overwrote the defender with our preserved attacker. All right. So this switches the roles of those guys. All right. Now, how long do we want to keep fighting? Till somebody dies, right? So, because this obviously is a fight to the death. All right. So we need to have this in a while loop that only ends when somebody's died. We internally handle that right now, do we not? Now, is it possible that just with some bad luck that this thing could run and they're sitting there fighting for forever and it never actually ends because either somebody has a really high armor class and we never clear it or whatever? It's possible. So how can I write a loop that keeps running forever unless I internally break out of it? Effectively, a problem-solving technique here is we can write an infinite loop, a loop that would not naturally end on its own. Good. Yeah, so typically when we have a loop, whether it's a while loop or a for loop, remember we kind of get back to this idea of what are our different kinds of loops and what do they lend themselves to? So for loops lend themselves to counting type problems where we know exactly how many times we're going to have to do something. Do we know how many attacks have to happen before this fight's over? No, it's random, right? You could use a for loop, not the end of the world, but it's not conducive for it. A while loop lends itself to problems where we don't know how many times it has to spin. We're going to have it go until some condition is met. Now, we could have done it where the while loop, where we maybe set the defender and the attacker at the top. So maybe the while loop is based on the, as long as the defender is still alive or something like that, keep doing it. But since we're internally breaking out, we're taking advantage of our knowledge that the return keyword gets us out of a function, also gets us out of the current loop. I think there was a question last class about the difference between break and return. Break makes a function immediately end. I'm sorry, return makes a function immediately end. Break makes breaks you out of the most local loop. So if you're currently inside of a loop, regardless of what kind of loop, and you have a break statement, you get out of that loop immediately, past the end of it. We also have a third similar type of keyword. Anybody know what the third one is? I think I'd mentioned it in here. Continue. Continue basically just skips the rest of this loop through and moves on to the next one. But a continue in an infinite loop would sort of kind of be a waste of time, other than the fact that it would skip the rest of the code that's below that inside the loop. So continue is probably less common. Go ahead.
So like if we have stuff after this loop and we want to leave but continue, we put a break.
Correct. Yeah. So what he's asking here is, what if when the person's dead, after the loop I'm about to put in is done, but I actually want to do some additional stuff. Maybe you thank the crowd for being here, whatever. You make sure everybody signs their waiver. You saw nothing. If we wanted to put some logic after the fight, and we said we don't want to get out of this function, you're right. We would use break to get out of the loop. So we stay inside the function, but get out of the loop. So let's go ahead and put our loop up here. So we'll go ahead. We're going to start off having our couple of players. That's not something that's going to be inside the loop. So really the fight starts when the attacker attempts to attack the defender. So we want that stuff to be inside of a loop. So now I'm going to grab the rest of this code. We'll put that inside that while loop. Oh, here. Maybe you've seen this before, but I'm going to go ahead and highlight this. I think the beautify thing does whatever only what I have highlighted, but I don't remember for sure. Yeah. Seemingly at least. So if you click the beautify thing up here, it'll indent all your stuff and things like that. Otherwise, you could just highlight the stuff you want to move in and hit tab. All right. So forever, we'll just put a little note. We internally break out as part of the logic. Just to give a little explanation of, hey, that's a loop while true that runs forever. So we have a way internally to get out of this loop rather than allowing our Boolean expression up there to be the trigger. Is that a Boolean expression? What's a Boolean expression? Any expression that boils down to a single value of true or false and doesn't become any more true than the hard-coded literal value true. All right, so attacker will try to hit. If everybody's still alive, attacker and defender switch places. We spin back up, we do it all again. So this loop will keep running until somebody dies. Make sense? All right, so go back into main. So we have our players, we have our arena. We named this guy. We probably also want to throw in some stats of who our people are, I guess. So what we'll go ahead and do right at the top of this is we'll say this dot p1 dot display, this dot p2 dot display. So inside the loop, before we start throwing punches, we'll just have both of our combatants display themselves. We won't switch their orders or anything. That way you get used to looking at the two people. So we won't say current attacker dot display, current defender dot display, because those guys switch places each time, and then Mike and Dave will be printed in different order. So we'll just keep our players static, and we'll just see hit points adjust as we go through. And the name of this function was start fight. So we'll say ring dot start fight. And this should have them fight to the death. Ha! Yes. Check him out. All right. How did he start? Oh man, my brother's pretty tough. Is it really going that? Hey, look at that.
Sixty's pretty tough to get over.
Strength is sad.
Well, the strength and mine are similar, and we're not even using
Yeah,
strength
this-
currently. Yeah, we're not even using strength. I guess we could just make the attack be their strength.
Do you strength as like a
Modifier typically. Yeah. Yeah. I mean, we can say, okay, if you're, for every point that your strength is above 8, you get an extra, yeah, well, yeah, whatever, an extra 1 point of damage. But right now we're not using it. We just fight back and forth. We see that hit points 22 and 17, 22 and 17. So we got some misses in here. Dave swings and misses. Mike swings and misses. Critical miss. Of course, my brother's critically missed. So you got your back and forth stuff there. All right. So questions about any of that stuff? All right. So I'll hit save on.
Do we have homework?
I'm not going to give you homework for next class because we're going to set up for that one, but there'll be homework over the weekend.
Good.
All right. So I'll put a link to this code up on Slack as soon as I get Slack installed on this computer, which I'm going to go do right now. So you have a link to the current code. And I will see everybody on Thursday.